Let us try an example to check the stresses in a prestressed beam. A rectangular beam has the following specifications. The cross-section is 150 times 300 mm. It is simply supported over a span of 4 meters. It is subjected to an uniformly distributed live load of 10 kN per meter. There is a straight tendon having the forces of 200 kN. The eccentricity is 65 mm below the centroid of the sections, and the concrete strength at surface is 30 Newton per mm square, and at transfer is 20 Newton per mm square. The questions asks us to calculate the corresponding stresses at the midspan and at the end of the member. Next, you are asked to check the stress limit if the flexural crack is allowed. You may pause the video for a while for you to work out the solution. To solve these questions, first you need to determine the beam property. You need to obtain the self-weight of the member, which is calculated by multiplying the cross-sectional area with the unit weight of the concrete. It is found to be 1.12 kN per meter. The cross-sectional area is obtained by multiplying 150 with 300. The section moduli for the rectangular sections is given in these equations. The z top and the z bottom will be the same, which is given here. Next, determine the load. At the transfer stage, only self-weight contribute to the member. And at the service state, the self-weight to be plus with the live load. The load acting on the member at the transfer and at the service states are given here. Next, calculate the maximum and minimum moment acting on the beam. This equation is for simply supported beam, which is WL squared per 8. The moments are obtained here. Next, you obtain the equations to determine the stress acting in the beam on top and bottom fiber of the beam. Check for the midspan first. The relevant values are given here. There is an eccentricity and there are moments acting at the midspan. Substitute this value into the equations. You will obtain the stresses at every single part of the beam. Next, you determine the stress at the support of the beam. There is an eccentricity, but there is no moment at the support of the simply supported beam. Substitute the relevant value into the equations. These values are obtained. The stresses at the transfer and service for the midspan and support are listed here. The compression limits refers to 0.6 compressive strength of the concrete. As the compressive strength of the concrete at the transfer stage is lower, therefore the limiting value will be lower. As the flexural crack is allowed, the tensile stress limit will be determined by FCTM. This represents the equations for the concrete smaller than 50 Newton per mm square strength. The value FCTM may be referred from Table 3.1 in Eurocode 2. It is in the functions of concrete strength, which at the transfer, the smaller concrete strength is developed, thus a smaller FCTM is obtained. The stress found from the equations are within the limits of compression and tension. Therefore, the entire beam section is considered acceptable.